Hello, I'm Richard Goering, and I'm speaking with Naveed Sherwani, who is President and CEO of Open Silicon. Now, Open Silicon is a fabless ASIC and SoC design company. Naveed, can you tell us a little bit about how Open Silicon works?
Thank you very much, Richard. Open Silicon is a company that was founded on the principle that the predictability and reliability is the most important thing that our customers need in ASICs. We started out as a very conventional ASIC company in which we would take RTL or netlist from the customers, do all that is required, package, test, physical design, get the chips in a working stage, and then supply silicon to our customers. In recent years, we have moved from that to become what we call a derivative company. Derivative company is the one which does a spec handoff to an existing chip, and our customers let us know what changes that we would like to make a chip, and we do that in 4 spaces: networking, telecom, storage, and computing. Open Silicon has the capability of taking a chip and modify the chip to a new customer spec. So that is kind of the reincarnation of Open Silicon as a derivative ASIC company.
All right. And what process nodes are you working with?
Currently, I think most of the chips which are going into silicon are at 40. Most of the design is moving to 28. We have just completed our flow development at 22 nanometer.
Okay, great. Now, you recently announced this On-Time or On-Us program, which I think is a kind of a unique thing. How does it work?
Well, we have got a lot of interest from the market on this program. The idea of the program is very simple, that if Open Silicon, based on the schedule that we have committed to you, we are unable to meet the schedule, which basically means if we are even 1 day late in delivering the working Pro Tools to you, Open Silicon will refund the design and RE back to you. Whenever we say something like that, people say, oh, that basically means that you're going to inflate your schedules and then try to meet the inflated schedule. Well, it is my belief that we don't set schedules, customers and markets do. Only we can do is that meet or beat that schedule. This program is actually based on our 8-9 year of research on how to build believable schedules, how to meet schedules, and all the operations research that we have done in critical buffer management, which allows us to build much more scientific schedules than I believe anybody else in the field. And this offer is based on statistical analysis, is that how many chips are actually late in Open Silicon, and if they are late, how late are they? And based on that analysis, then doing financial analysis of that, we know that we can actually offer something like that and not lose money doing that. So this program is more of a statement by Open Silicon that after 8 years of research, we have reached a point that we can offer and we can put our money behind the statement that many people make that they are predictable. We are the first company in the history of semiconductors that we are putting our money where our mouth is.
So this suggests that you can look at a chip, you can look at a job, and have a pretty good idea, is it going to take 5 weeks, is it going to take 8 weeks?
Absolutely. I think because we work in a narrow field, in the areas of networking, telecom, storage, and computing, because we have done 250 odd projects in the last 7 years, based on that, I don't believe that we get a project which is completely off of the left field. We get most projects which we have seen something like before. Secondly, we operate in derivatives, which means the project is well known to us, project is well known to the customer. So in that arena, you should be able to predict the schedule much more than in a completely green field ASIC development where you are pushing the technology and doing several new things, IP is new, everything is new. We're not talking about those projects. Open Silicon is not about those projects. So I think in the kind of projects that we do, it is possible to do the scientific analysis and build a more believable and execution-oriented schedule.
All right. Now, are you using externally sourced IP for most of your SoC work?
Absolutely. We use a lot of pieces of IP from many different vendors.
Okay, and this raises a question. What if there's a schedule delay that's really due to one of your IP providers?
Yeah, that's a very good question. So in this program, we are not saying that all the IP initially will be in the program. So what Open Silicon is doing is that we are not even offering all the fabs. So there are certain fabs, there are certain package houses, there are certain IP vendors that we trust, believe that they have the same schedule commitment as we do. Others don't. So initially, when the customer will approach us with this particular chip, we will look at the IP list, we look at the fab selection, package selection, test selection. Based on that, we can say that have we approved all of these people? Have we worked with all these guys? And we believe they have the same schedule commitment. So we believe that that is actually making a very bold statement about those pieces of IP that we put our name behind that because we know it works. We know that we have integrated it. We know that we can do that in time. So eventually, we hope it will motivate the IP vendors to get into the program and try to work with us to certify their IP as well to be also on-time IP, not just making claims about, oh, we know our IP works. Well, we have to make the IP work in that particular application, in that particular integration environment, and make the silicon work the first time.
What's the quality of the IP you're seeing these days? Has it improved, or there's still some rough areas?
I think the basic issue I see with the IP industry is that people who are selling IP are not the people who sell silicon. As a result, there is a big gap between people who know the silicon and people who know the IP. So most of the IP vendors that we meet actually have maybe one test chip or two test chips. And they are selling IP to major silicon providers. But the major silicon providers then don't share their yield data, their experience or back with the IP vendor. As a result, IP vendors are mostly depending on the test chip data, not the real silicon data. So what Open Silicon has to do is to put that IP into pieces of silicon. Since we sell pieces of silicon, millions of them to our customers, we have our own yield data, we have our own integration data. We use that data to see if the IP will work or not work. So that is what I see as a major issue in the IP industry, is that IP industry is consolidating, but unfortunately the consolidation is happening under the banner where the people who don't sell silicon don't have real silicon experience. I don't consider doing one test chip or two test chip as a silicon experience. I believe silicon experience comes when you have integrated a piece of IP into a silicon, in fact many pieces of silicon, run many million units, and see how when the process shifts, when process moves, what happens to that IP. Because we push the IP to the limit, there are many marginality issues. IP that may initially work in a test chip may not work in a real environment, may work but may not work in a high volume environment. So I think that I see as a major issue, that small IP houses don't have wherewithal to do even the test chips. Bigger IP houses do test chips, but I think it doesn't cut it. We need to have a very strong partnership, people who sell IP and the people who actually sell silicon with that IP in it. Only then we can get the real data that is needed to build on-time, predictable and reliable silicon.
Now, do you develop your own IP and do you sell IP?
Yes, we do. On very limited cases, we have done that when we feel that pieces of IP are not available in the market. We have a very strong position in IP core called interlocking. In fact, to the best of our knowledge, we are the only supplier of interlocking IP now. And in that particular IP, we have committed to the roadmap. We have, of course, a lot of silicon data behind it and so on and so forth. And as we expand our IP capabilities, we will select those IPs where we feel that Open Silicon can bring differentiated silicon proven, not test chip proven, silicon proven IP to the marketplace. We will develop that IP and bring it to the marketplace.
Okay. Now, aside from the quality issue you mentioned, what challenges do you run into with IP integration and verification?
I'm a person who has said for last 7-8 years, it is not the IP, it is not the layout, it is not RTL, it is the verification. That is the biggest challenge that faces hardware industry. I believe that unlike many other industries, in particular software industries, we have not developed our verification system in a hierarchical method in which starting from students going to universities, learning verification as an inherent part of doing design, people growing up in the companies, learning how to do small chip design, inherently verifiable. As a result, what we find ourselves in an exponential verification nightmare now. So it's not just about IP. I think the overall verification of chips has reaching a critical stage. If you look at all major microprocessors, they are not inherently verifiable. In fact, all major microprocessors are sold with very large errata now. Errata is a statement by the company saying that I can't verify the whole thing. There are states in the finite state machine that are not inherently verifiable. So as I see that as the chips are becoming integrated, they are becoming SoCs, which means chips have complete other chips in them which were not originally verified to begin with. You can see the exponential verification nightmare. IP only adds to that.
Yeah.
So I think as an industry, we have to commit ourselves to becoming an IP reuse. Reuse in a verifiable manner, which means if I take a piece of another chip, stick it to another one, that piece was already verified, and I am only now verifying the interface. I'm not verifying anything else. Believe it or not, we have customers and we have chips that we have looked at. They're not even flop to flop inside a block, which means timing paths run through multiple blocks. So you can imagine that it is not even possible to do any timing verification without having to take several blocks instead of just one block at a time. So I think verification is a huge challenge for our industry, and unless we start, where I said, from the textbooks, from the universities, to people growing up learning verification and making verification and reuse as our daily life, something I am working with our customers saying that if you're going to do one chip with me and not reuse it, I'm not sure if my engineering should be spending time on doing that.
Yeah.
We should do everything that is reusable, and then maybe 80-90% reusability, 20-10% integration. But that's way how we can conquer this verification nightmare that we are walking into right now.
Okay, well said. Thank you, Naveed.
Thank you very much.